Hello, my name is Adam Bean and welcome to the Java for Kubernetes J4K IO conference session about using MicroProfile to increase robustness and observability of your apps and services. And what I will do, I implement a small app. If you need more examples, what I also did, I pre-recorded an online workshop, apps with MicroProfile, 8 hours workshop. And it comes also with the examples, and you can fetch the examples or clone the examples directly from GitHub, MicroProfile training, and it also comes with all major metrics, fault tolerance, health, and even open tracing implementation. Okay, so what I would like to do today is to talk about MicroProfile and robustness. So I'm a consultant working with Java since 25 years and for 25 years, and I really like it still. And I'm consultant freelancer helping companies with backends. This is like lightweight, no dependencies, MicroProfile Jakarta E services in clouds, private, public, and in front ends the same actually. So using building applications without dependencies, without frameworks. Okay, now I maintain a blog for since I think 2006, and what it is a notepad. So if I write things, not to forget the stuff. And AHEX.io is a set of pre-recorded online workshops or videos. AHEX Lives is very similar to this session, but it takes the entire day is a workshop, and this is live, not pre-recorded, rather than a live virtual workshop. With chat and so forth. And AHEX FM is a podcast where I just invite people and talk about various things, like, for instance, MicroProfile, Jakarta E, Quarkus, stuff from that. Okay, now, if you have any questions left, first Monday of the month, 8 p.m. CET, I try to answer all the questions for month, but I don't answer any questions via email. So if you ask me something via email, I will probably redirect you to AHEX TV, and this is redirect you to a gist, GitHub gist, where you can just write your questions down. Okay, now on the next online workshop is in December. A MicroProfile with Quarkus is very similar to what we're doing right now, but it covers not only fault tolerance but all aspects. Okay, now what is MicroProfile? Start with that, and then I would like to talk about health, metrics, and fault tolerance. And what is MicroProfile? For me, MicroProfile comes with additional added value to the stable Jakarta E APIs. So MicroProfile comes with, for instance, Prometheus metrics, fault tolerance patterns, health we talked today, and REST client, and open tracing. And this APIs are not available in Jakarta E. They come on top of Jakarta E, and they are many of such APIs are the implementation of cloud native foundation standards or specifications, whereby the Jakarta E APIs tend to implement a Java standards, like, for instance, CDI, context and dependency injection. JSON-P, this is the lower layer, is serializing object back and forth using more or less hash map-like structure. JAX-RS is exposing POJOs with view annotations via REST and HTTP, and JSON-B is binding. Okay, this was the last slide. So let's start with the implementation. And what I would like to do is I would like to implement two microservices, let them communicate with each other and talk about robustness and patterns. So first, I would like to create a service with a Quarkus service, and it will generate random numbers because it's J4K random, because it's easy to implement and the project version is fine, REST resource ES, and this is fine. This is also somehow fine. R&D would be better, but too late. So, and open Visual Studio Code, and let's try to implement something. And what I would like to do is I would like to implement this hello resource, and not to forget that I would like to start this thing on a different port, because I would like to work without Docker today, and I cannot start just two applications with the same port. So just use the port, let's say 8082. So this is the backend, and the frontend is going to run on the default port. So, and now this, instead of hello, I would like to use RND, and instead of return hello, I would just do something like this. Just, it's not exactly random, but almost. Or make it a little bit more random, actually. So still not perfect, but a little bit more random than current time list. So we have that, and so let's start the service, compile Quarkus dev in dev mode, and see whether it works. Okay, so what I would like to do is just to see whether it works, and this is going to be localhost 8082 / and RND. Seems to work. Now the question is, how often this method was invoked, because if we are building another microservice, this is a little bit problematic to go with that and call it via curl. I'm interested to know how often this method was invoked at all for debugging purposes or tracing purposes. So how to do that? Fairly easy. So first, if I would just try to fetch the metrics, and this is standard in MicroProfile, they are empty because they are not installed. And the same is true for health. There's just the basic health, and or not even available. And yeah, so what I would like to do is to add the metrics, and with that I'm adding an extension, and this extension is called metrics. So it looks like magic, but it's actually trivial. What happens behind the scenes, this was just added, so stock Maven dependency, but it's more convenient with the IDE, and I don't like to use today the rest assured, and I also don't care about the unit tests. And remove unit tests, don't matter for robustness. Black box or system tests are more useful for testing that. Okay. So we have that, and what I could do right now is I could just add counted to see how often this method was invoked and whether it was invoked at all. So with that, not health, rather than RND. I call the RND and then metrics. Just do this, and as you can see, we see here, this is just additional noise with the -i. And what I see here, the method was invoked once, which is already useful, because if other services are calling me, I see whether I'm available or not. So this is already nice. So what is also possible, I can actually fetch the metrics as JSON, application JSON, which is a little bit more human readable, and this is directly usable from web apps. So you can create very easily a small dashboard to visualize your metrics. Of course, you don't have to do this because Prometheus provides and Grafana provide dashboard for you, but in smaller projects, maybe if you don't have Prometheus or Grafana, you could implement this by yourself. Now the question is, what is smallri? So you saw already that I use something with smallri. And if we take a look on smallri, this is an open source project. And for me, it is more or less like the reference implementation for the MicroProfile APIs, which is not true, but this is like, almost the default. Like Weld for me was like the canonical implementation of CDI. So smallri is like the implementation of the MicroProfile APIs and used by Quarkus and other servers. So there's like shared implementation. And we just added the metrics, and what we also will do, add the fault tolerance and health. So I think our backend service is done. So what we could do, we could add, the health checks, but it's boring. I would add the health checks in the front-end service, but I think this is just good enough. And so what I would like to do is I would just stop the dev mode and just run the production mode. So let's assume we are already in production. So now Let's start the service. Nice. Started on port 8082. Perfect. So I think even we can just close this because it is in production. So now let's implement another service, and I would like to call the service message. And actually J4K. And here I would like to create a service with the name message or messages J4K, and name of the service is messages. Messages is nicer. Yes. And let's go indeed with hello now. Messages, and I would like to open the IDE again. So now what I would like to do is, now I need a couple of extensions, and for time reasons I need first, or no, I don't need it really, but I would like to use the REST client to add to call the other service. I would like to use the smallri fault tolerance, and whatever starts with smallri is this MicroProfile, so fault tolerance, matrix, and health, everything smallri, and this basically was, hopefully. So now all the metrics are added, and to speed up development, I will delete the tests, and then I don't need the JUnit 5, I don't need the rest assured, and this is all. So this is all the extensions we are using. So now I would like to start with the dev mode here, and it should actually work because it uses the 8080 port, and it works. And now we can start coding. And for this purpose, I would like to introduce, and in this session, I will just put everything to one folder. And in the next J4K session, I will tell you that it was actually completely wrong and structured it a little bit nicer. So what I would like to do is to add a class with the messenger class, which will pull the messages, and class. And also at the same time, actually wanted to start with something else, is the random numbers, and this is going to be an interface, and this is the REST client what I wanted to use. This is the interface, and this is an interface, so I have to say register REST client, because it is going to be implemented by MicroProfile or by Quarkus. The config key is RND. And I would like, for time reason, just skip one thing and just return response. You will see in a second why. Usually I will start with string and then explain why string in this particular case not a great idea. So just go with response and just call the method next. And what this method does is actually... So what this method does, first I have to import this response. So what this method does is the following. This get, it produces text plane. This is the media type text plane. And this basically was. So it almost configured. So what I have to tell the server now, what is actually RND, and this works with the configuration key. And the RND URI is http/localhost, and now I have to be careful, 8082/nothing, because I think it's better to tell that this is the actual resource. So just go this way. So now I'm done. So this is the communication layer, and I'm able to communicate from the messenger to the other service. So let's do this, request scoped. And I can now inject my REST client And the REST client is the random numbers. And in real world projects, I call always this random numbers client, that to make it obvious as an interface, but forgot about that. So let's say numbers, and then start with a method. And this method is going to return a string, and this is going to be the actual message. And let's see whether it works. And what we have to do is to do this var response equals numbers dot next, and then return response dot read entity. And I would like to have a string. JSONB, of course, would work as well, but it doesn't matter in this session for the session. So just string is the easiest possible thing. So just go with the string. And the hello resource is I have to inject my messenger. And I just create the messenger class to be a little bit more real world. I don't think you will implement everything in the resource. So messenger, and then call here messenger dot message. So now we have it, and make a little bit nicer message. I will also need a possibility to save a message for later. So so I will just go with that, save a string message, just and say this messenger save the message, and this is going to be post, and it will consume media type, also text plain. Okay, the save is not available, so make it available. And now here we will just write down that we are saving. Okay, so that's for now, and see whether it works. So open curl localhost 8080/hello, and we should see something. And we already see unable to invoke. Let's see why. So random numbers is RND, is HTTP localhost 8082, which is fine. And we have get, it produces path RND, it produces this next. And we got connect to localhost, so it cannot connect. And I think it cannot connect because I killed the server, which is problematic. So let's see. RND Java -jar target runner, and see. Now it's better. So with a backend service, it works better. Okay, so now it seems to work. Now, of course, is the question to know how fast is it here. And so what we can do, we can add here an annotation called metered, for instance. Metered, and which adds additional insight how fast it really is. So let's call it again and go to metrics. And actually, I think it is nicer to do this from here. Localhost and is 8080/metrics. So I see all the metrics, which is not really convenient because of low-level metrics, even from the garbage collector. I think what we are interested in are just the business metrics. And we see already it is this was invoked once, and we see some basic metrics, how often it was invoked per second. So we see here. So this is the metered. Okay, so now we have the basic, not highly relevant metric, but at least something here. So, and the problem we have here a little bit is the following. So if I kill the server and just do something here, so this arrow here is a little bit problematic. So, and the problem is we get actually 404, which results in processing exception, which is going to be, I think, the client error. And so what we can do about that is to make the error handling a little bit better. And for this purpose, what I would like to do is first, I would like to say, I would like to have implement a fallback. And in case this method throws an exception, I would like to call another method. And this was actually the reason why I started with the response here. And I would call the method is backend not available. And just copy that. And this method is going to return a response. And this is the name. And then I can just return response, the status, which is 503. And then just build that. And this is an interface, forgot about that. So this has to be a default method. So now let's try again. So I would like to do this. And it is almost identical. The problem is it says input stream was empty. There is no entity. So the problem here right now is that we have here in the messenger, we just invoke next. This is the response. And then regardless what happens here, we proceed with read entity. So now, which always causes an error, which is fine. But what's interesting, if we just rerun this, what we see here, that the fallback contributed some metrics, and we see actually that the fallback was called once, and from one invocation was problematic. So without any additional metrics implementation, we got additional counter, which counts how often the fallback was invoked, which means the backend client was not available. So now, what we could do here, of course, we could say in case, you know, here a problem happens, yeah, what we can also do, we can say, okay, now do this. I don't care about that. So fallback, and this, of course, doesn't always work. So I can say fallback method, and this is a default message, and this is has to have the same signature, public method, string, default message, and the default message is return message without ID. So so what happens now if I retry that? I get message without ID because this fallback kicked in. And we also will see there's additional fallback. So I can just make it larger. There's additional fallback. We have the messenger message fallback and the random numbers fallback. So both fallback were active. So now to improve the situation, what I can do is I can say, okay, but I would like to retry because it may be that the service is not available for a brief moment, and afterwards it is going to be available. And as you can see, there are lots of, I can just introduce some jitter so it doesn't retry every few seconds. But I would like to do, just say, try 3 times and then give up. And for this purpose, just add another systrace log, another log, just to see how often this was invoked. And so try this. Takes a little bit longer because it retried 3 times, and let's see. So messenger default message. It's of course an error. So what I have to do is, of course, is to put it here to see how often this retried. So let's do this. Now it looks better. Okay, so do it again. Okay. So this was the basic retry and fallback. So now let's implement a health check. So what I would like to do is we are actually in the messenger. So we can implement a health check. So how to do that is we have liveness and readiness probes, and the Quarkus already ships we activated the health extension. So it should actually already come with basic health information. and it comes, so it is empty, but at least we don't get 404 rather than 200. Yeah, 200. So let's implement a sensible health check. And liveness checks mean if the liveness probe returns something which is not a success, a 200 range. So the pod is going to be restarted, or the service is going to be restarted. And readiness probes means if the service is not ready, the load balancer will won't send any traffic to the service. So let's start with the readiness probe. What we could actually do is we can actually misuse the random number generator, this method, because it's idempotent, as a synthetic transaction. So what synthetic transaction means is like a fake transactions or fake invocations which are only used for monitoring purposes. So let's do this. So what we can do is I could actually implement here in the messenger exactly a health check, a method which produces a health check. And this is backend R&D availability. And this is going to produce, but this time it's the CDI produces. And I'm only interested in the liveness probe. So, and this will return, I will ask the numbers interface, this numbers dot next, and what I get back is the response. And then if, and what I also would like to have from response, the status from the response. And then if status is not 200, which is not perfect because I should rather ask the entire range whether it was successful, but is good enough. If it is 200, this is actually the interesting part. If it is 200, then I would like to return the health. Then I would like to return health check response up, and the name is R&D availability. This is the name of the service, and yeah, and otherwise return health check response dot down and R&D availability, and just use the underscores. And actually we could introduce a variable, but for now down. And actually we can provide more information with the builder than with data, and say why it's down. So I can say the status is status, and then down this, and then I think build even. Let's see. Builder. So with data. Okay, let's see. I think then I have to do named this way. So named, and then go with that. Right? Now looks better. Let's see. So down 503, which is true. And just start the service. And now we get still 503. Impossible. So we get the message and health. We still get the service not available here. And you say if status equals 200. So we do is up, get status, the next, and then we are building the probe. What? And the next, it is not available, we return. So actually it should work. So what's going on? So 503. So let's just reload the application server and try, or the runtime, and try it once again. Yeah, it works. There was some compiler error. So now it works like expected. So if we will kill that, try it again. So okay. So we implemented a liveness probe. What about, oh sorry, readiness probe. What about a liveness probe? So a liveness probes in our case is fairly simple because there is nothing, you know, to check. We don't have any resources. I would just implement a probe in a standalone method and call the method a standalone class liveness check or probe, and actually, yeah, just put it this way, and this is going to be a liveness and application scoped. And what happens here, this will implement a health check and return and now return the and now implement an interface, not only return. We have to implement an interface which returns the health check response. Now, health check response, and we just say up, and this is messages. Good enough. So with that, we can just ask for the health. And we see the messages are up, R&D availability is also up. And now we can distinguish between the liveness probe and ready. This is the ready probe, and I think messenger liveness. So there is still health, both live and readiness should be here. Readiness. Ready. Okay, now we have ready, and we have also the live probes. Okay, looks good. Now, what about the hello resource here? So why I prepare that? Because now we can actually send or save messages. And for this purpose, I will have to say I would like to use the post method, and the content type is going to be text plain. And what I'm sending is the data, and the data is Duke. So this should work. No content, looks good. So try that. And messenger safe. So why I'm doing this? Because what we can also do with MicroProfile metrics is to add a more inside, what's actually going on inside the application, which is not easily possible with service meshes and stuff like that. So for instance, what I can do is to inject a metric registry and the type is application. And what I would like to do is the metric registry, the registry. So, and the great thing about that is the following. I can now say, for instance, I would expect that the messages, I could use bin validation for that, of course, but for now, I could say a message, a valid message should contain a Duke. And here I can say this registry counter and create a counter on the fly. And the on the fly counter will say if this is not a Duke, then the counter is going to be increased, and the name of the counter is not a Duke. But if it is a Duke, so I can just have the counted. So now I see the total amount of messages, and of course what I can do is if message is null or message size length is smaller 2 and something, you know, this registry so too short message. So now if I will try to invoke the service again with that, I will get nothing. I think I have to restart the Quarkus. Do it again. So we do the save in Messenger and the hello resource invoke save. Yeah, message and it contains a Duke, of course. So it is perfect. So it works as expected. So if we do a nuke and repeat that, go to application, then application not a Duke total 1. And if we, for instance, try to send a message which is too short, so we get too short and not a nuke. So the question is what happens or how to deal with that. We actually don't like to save the message. So how to recover from such an error. So what you could do is you could create your own exception, or you could use the built-in exception. For instance, I could now say throw new bad request exception, which is part of JAX arrest. And now we say this is too short. So I can just add additional information here, could add. So now if we try this, what I get back is bad request, and the counter is increased in bad request. And let's say with not a nuke, I would like to create my own custom handling. And for that, I would like to create an exception, and this is called not a Duke exception. and the not a Duke exception, it would extends from web application exception. And there is a constructor. And in the constructor, I would expect the message. And what happens here is I would like to pass to super my own response. And this response is going to be status is 400. It's bad request. But I can add additional header. Info. And just pass the message as info. And create the exception. So now this not a Duke exception. Not a Duke exception. Have to be built in here. Throw new not a Duke exception. And just put the message here, for instance. Okay, now if I say nuke, which is obviously not a Duke, then I get bad request info nuke. So this was the additional information, but the services or the counters are still working as expected. Okay, now what we can also do with that is in the messenger, we are actually calling the other REST service, Attendee, and what we get back here is the response. So what we can do very easily is to do the following. I can say this registry, please create a counter. And the counter is Attendee invocations status. And then add the response get status and then increase that. So now, if I call the service now via 8080 hello, so what I get back is I should see here application Attendee invocation status 200. So what will happen right now? It will automatically create a counter for every new status and increase the counter on the fly. So I think we are done. This were the basics. What you could of course do is implement some throttling with fault tolerance with BulkHeads. So it is very powerful and without any external dependencies. Actually, it comes with ships with MicroProfile and is available on all runtime on Payara, Helidon, OpenLiberty, Tommy, and even Quarkus, or even especially Quarkus. And what I did, for instance, just an idea in the, can I actually show you the code in the blockpad implementation. So I will just switch to that. For instance, there were more reasonable implementations. Just an idea. So what we can actually do is the following. We have in the content. So this is two pieces. The reactor renders and content stores files, the blog posts. So the health checks in content, if we take a look on that, are the following. Are, for instance, posts control post store. And what I have here is the following. What I can do is I can say, okay, there is a liveness probe whether the directory for the post actually exists. If it doesn't exist, it doesn't make any sense to keep the pod alive. There's another liveness probe whether the post directory has space, whether the directory has enough space. And there's a gauge which exposes how much space do I actually have. So there are some ideas what we can do here with health checks, and so this is the content, and the reactor communicates with the content. So what the posts resource here, what happens here is I'm throttling, for instance, just 2 threads are able to invoke this method, and otherwise the fallback method is going to be invoked with overloaded server. So this is the fallback implementation. And what we also have here, health checks. The health probe is interesting. What it does is it checks, for instance, this is the liveness and readiness probes. It checks whether the content is available. If it isn't, it doesn't make any sense to proceed. So this is like, you know, the simple probe. What I also do is I check whether I can actually fetch a post which the name is initial. It should always exist. So this is interesting. Another idea for metrics is the following. So in the content provider service, I have here the post store. And what happens here, for instance, is there are two counters, and the one says, okay, increase hit count. That means I actually fetched a post. But even more interesting, this counter gets increased if in case someone tries, you know, to find a post by title which doesn't exist, which actually cannot happen. So someone will try, you know, to spam my blog post engine or whatever. And this is also a counter which gets increased. And we could actually add even alerts, so to alert me or an administrator that the posts, or there's no post with such title. Okay. Then thank you for watching the session, and see you at the other J4K conferences or at online workshops. So thank you and bye.